Okay. Are we ready to start, everybody? Excellent. Thank you so much, everyone, for coming to what I hope will be a very lively and interesting panel on the State of the Union for AI. I'm Nova Spivak. I'm the CEO and co-founder of a company called Bottlenose. That's bottlenose.com. And what we do is we analyze trends in big data by looking at about 72 billion messages a day to find patterns for big brands using natural language processing and statistics and other techniques. I have a long background in AI in a number of companies doing information filtering, machine learning, the semantic web, and big data. And today, I'm really pleased to have some amazing panelists with us. I'm going to introduce them, and then after that, I'm going to introduce you, and then we're going to get into the content today. So, starting next to me, we've got Monica Anderson. And Monica is the founder and CTO of a company called Sensei Corporation, and they're working on next-generation search and big data algorithms for making sense of large, unstructured, text-based data sets. Previously, Monica was the founder and director of research at Sentience, a research company with the goal of creating an understanding machine that was capable of learning any human language using unsupervised training from text and a deep learning algorithm called artificial intuition. She's worked on AI and data science for Cisco and Google. The next person next to me is Fred Brown. Fred, also known as the Cowboy CEO, is a natural language understanding software pioneer and serial entrepreneur who's been part of launching 12 companies. And in his latest venture, Next IT Corporation, he's the CEO and founder, and they are the largest deployer of enterprise AI and virtual assistant technology today. Through their AllMe AI platform, they're personalizing humanizing user interactions with technology. Prior to that, Fred was founder and president, CEO of Linesoft. He was also a calf roper and broke new ground in the energy industry with the development of software systems that are now standardized in that field. And then finally, last but not least, Doug Lennett, who's a legend in the AI space. Doug was a professor of computer science at Stanford in the 70s and 80s. And in 1994, he founded Cycorp, C-Y-C-O-R-P, which has been described by Business Insider as the most ambitious artificial intelligence project in the world. Definitely, that's true. They created something called Cyc, which is C-Y-C, that combines an unbelievably enormous common sense ontology and knowledge base with a powerful reasoning engine and natural language interface to support knowledge-intensive applications. And there's actually, I believe, an open source version of Cyc that you can check out. So Doug has pioneered research in the areas of automated discovery, machine learning, knowledge representation, blackboard systems, ontologies. He's a fellow of the AAAI and AAAS, and a winner of the biannual Computers and Thought Award. So we're very pleased to have this distinguished group of AI pioneers and leaders with us today. Before we get into the content, I just want to ask about you. So we can choose our own adventure today. And to do that, I need to know what you want to do with this panel. So I'm going to ask for a show of hands. First of all, how many people here actually use some form of AI in their job? Raise your hand. Well, that's pretty good. How many people here would consider themselves to have at least a somewhat technical understanding of AI? They're not new to it, you have somewhat technical understanding of the techniques and the ideas. Very good. How many people here would like to get into some kind of geeky details today? Oh, wow. Well, you're in luck. All right, so we're not necessarily going to have to keep it super general. We'll get into the real nitty-gritty of some of these issues then, because it seems like we've got a lot of people here who are either hands-on or at least very familiar with AI, and so we'll dig in a little deeper than we might otherwise dig in. So first we're going to start with some general questions. I'm going to ask the panelists, and then we'll get into some more detailed, deeper things, and then at the end, if there's time, hopefully there will be, we'll take questions from you, and if you have those questions, you can come up to the mic. So the first question for each of our panelists is, give me a one-sentence definition of what you think intelligence is. Go ahead, we'll just start with Monica.
So in my opinion, intelligence is the ability to know what matters. It's the issue of salience. If you look at a complex picture, a complex situation, can you figure out what is important and what can be discarded if you want to reason about it? And that's something computers, as far as I know today, cannot do.
Can you hear us in the back? Yes? Yeah, okay, great. Fred?
So I think it's being able to understand what a human tells you and then being able to make that actionable and help give them an answer or do what they want to do.
So I think intelligence in many ways is in the eye of the beholder. If you search a smaller space to get an answer to a problem or a question than I would have searched, then I would say, oh, you must have been intelligent in the way that you went about that. Maybe that's because of some ignorance on my part. You know something that I don't. Maybe it's because of some misinformation that I have that you don't. Maybe it's because I did something illogical and you didn't, or maybe it's just a kind of shallow thinking thing, where if I had just worked a little bit longer, I would have gotten the answer too.
So then what is artificial intelligence? And what should the goal be of artificial intelligence? Why don't you go ahead?
So this is a very deep question.
We can go in the other order.
Yeah, go the other way.
I'll give this.
Go ahead.
So if you think of artificial intelligence, it's essentially doing human-like activities. So you're taking something that a human can do and you're automating and giving it human-like activity. So if you're doing that and you're intelligent, it really means that you're doing human-like activity and you're being helpful or useful to the human user on the other side. So it's about acting like a human and then being helpful or useful to the end user.
So I would go further and say it's really about amplifying our minds in much the same way that steam power amplified what our muscles could do 200 years ago, what electricity amplified what our muscles could do 100 years ago. So with AI, we ought to be able to solve harder problems, be more creative, misunderstand each other less, do more things in parallel. It's that kind of power that will make us smarter as individuals, and hopefully then smarter as a species.
I would like to go a little bit deeper than just saying it's behavior based, which has been to some extent the traditional way of telling whether an AI is good or not. I like to say we have to have AIs that have actual understanding of the world, that understand things the way, for instance, teenagers do. Children learn how to understand the world based on what we can call unsupervised learning. And we have to get to the point where our machines can learn in the way that children do, everything about the world, and basically get to the point where they can learn autonomously and autonomously decide what's important.
And I'd just like to add that it's great if they can learn like children, but if they're not smarter than teenagers, I don't consider them to be actually intelligent.
Actually, I disagree with that, because something with a teenage level understanding of, say, English would be worth $1 trillion. And because you can have 1 million copies of that teenager reading web pages, classifying them by content and classifying them by topic and how novel they are, how useful they are. And having subhuman level intelligence is extremely important everywhere.
But do you think there are different kinds of AI? I mean, there's certainly machine intelligence and there's human intelligence, and they're different. Should we be trying to make machines like humans, or should we be trying to make humans like machines, or should we be trying to make machines like machines so that humans can be like humans? Are there different kinds of AI, and are we barking up the wrong tree by trying to make AI like humans?
The AIs we're going to see, are going to be very alien, at least initially. And we have to accept the fact that they are intelligent in spite of being alien. For instance, you can imagine having like a personal information manager that knew that you'd like to have an extra stopover in Chicago because your daughter lives there, and schedules your air flight accordingly. And they have to understand the entire situation in order to be able to do that. And so it's nobody would confuse that kind of a system with a human, so that's why things like the Turing test doesn't really apply. But we will still have to recognize that it is intelligent because it does things that an intelligent assistant would do.
What do you guys think?
I think that makes it human-like. I think we gotta separate what's under the covers from what is the user experience. So the same analogy where my assistant, my virtual assistant knows something about me and applies that to helping me accomplish a task, in this case, know that I want to stop somewhere, that is making it very human-like. How we do it under the covers is a completely different problem. I think users want to personalize, it's all about me as the user, right? So what can you know about me? What can you do to help me? Very similar to having a very good assistant that makes me more efficient. So when I say human-like, I'm talking about the end user experience, not what we do under the covers. There's lots of things under the covers we need to do in order to make it a consistent, repeatable, accurate representation of a conversation. But what humans are looking for, that's something that knows me, it does the kinds of things I want to do, it's helpful, it's accurate, and it's trustworthy. And as you're building these virtual humans, you can actually give them personality. And the behavioral psychology part of it's just as important as the underlying algorithms.
Yeah, so I'm slightly worried because I agreed with the other panelists on this, so there may be less to disagree than I thought about. There would be. But anyway, no, I think that in the early days, people thought about AIs as these sort of embodied robots that would be android-like, that would be humanoid-like in shape, that would be separate intelligences. And then I think Nova's question makes more sense in terms of do we want to go for individual intelligences which are similar or dissimilar to humans? But I think the real path to value in AI is saying that that's not really the question at all. The question is, how can we have personal AI assistants that work with us, that enable us to do things that neither we nor they alone could have done otherwise.
Now, are you guys, in your own work, are you using AI in some interesting new ways that kind of that exemplify this perspective? Maybe talk a little bit about what's new and interesting in what you're doing that sort of exemplifies what you mean?
Well, in the work I'm doing for Sensei, it's basically a data science platform, and we're using traditional natural language processing algorithms to get stuff done. And it's only borderline AI field. It was AI maybe 30 years ago, 20 years ago, and today is standard practices in the industry.
What about your earlier research
So
on
the
intuition?
research I was doing, the introduction said that I was working, I was creating systems that could understand any human language. That was the goal. We actually didn't get that far. We have some partial results in understanding natural languages, but the trick here was that we were building systems that did not initially understand anything about language at all. We call these model-free systems, model-free methods. You basically create a system that's a blank slate that knows how to learn, and then you decide which language to teach it, and you give it either English or Japanese or whatever language, and it would learn the language in theory from just reading unsupervised text, unsupervised training on plain text. And that's a pretty lofty goal, but we had partial results that were quite interesting, and I hope to get back to that research someday.
Sure, the thing that's got me excited that I'm working on right now is getting humans to give me actionable medical data, right? So once I get that data, it's data that doctors and clinicians don't have now that can help both the patient and the doctor manage their chronic disease better. The magic to that is actually the interface on how do I engage a human? How do I get them to talk to me? How do I get them to give me this information? What can I do when they're depressed? And the important thing is actually being indistinguishable from a human. They want the assistant to be funny and helpful. If I've got a chronic disease, it's kind of a depressing thing. And what can we do to add levity and fun to the conversations that you have with your virtual health assistant? And what makes it sticky and makes it engaging is actually a human-like behavior of being able to help you, engage you, make you feel good when you're feeling bad. So the thing that we've done is build these virtual agents, but applying them to the specific task of getting this data, so that we can do something to help. There's $1 trillion out there in the US healthcare system that, for lack of adherence, people don't do what their doctor tells them to do, and we're trying to make that better. It's really exciting.
So there are a couple things that are that we're doing that I wanted to mention. One is a project very similar to what Fred has been talking about in some ways, to try and make new medical discoveries, try and discover new cancer growth and metastasis pathways and new treatments, new unusual uses of existing drugs and chemicals that might be very specialized cures for cancer or controls for conditions like osteoporosis, and do that by combining two very different sources of power. One is the source of power that most people in AI are tapping these days, which is shallow reasoning on massive amounts of data. So as the cost of sequencing the genome has gone down from billions of dollars to dollars, there's lots of information about patients' DNA. And you can look at SNPs, you can look at little mutations and how they correlate with phenotypic medical conditions of interest. Those A to Z correlations, when you look at all that data, usually turn out to be wrong. They turn out to be artifactual. They waste doctors' time. And what we do is we combine those A to Z weak correlations with detailed models, causal models of how organs and parts of the body work, biochemical reactions, what takes place where, what leads to what, and so on. And then we try to put together, we try to spin a tale, A to B to C to X to Y to Z, that goes all the way from A to Z. And that also often turns out to be wrong, because we can rationalize almost anything. But then a really cool thing happens in the middle, say step J or K, some independently assayable, independently testable prediction is made, which we can then go back to the data and say, does the data confirm or deny this? And if so, the entire chain is much more likely, the entire pathway is much more likely to be true or false. So using that synergy between massive amounts of data and logical causal reasoning is one really cool thing. And the other thing that we're doing, which I wanted to mention, is that we're trying to use AI to revolutionize education. If you think about it, we've all had the experience that we really only understood something when we had to teach it or explain it to somebody else. And yet, if you look at educational software out there, invariably, the computer takes the role of the teacher, and the student takes the role of the student. So what we have is a different kind of educational software where we have our system, Psych, play the role of, in this case, a 6th grader who is very slightly more confused than you are all the time about math and science. And your job as the user is to advise them, watch them, help them, mentor them, tutor them. And of course, since we allow our system to know about 6th grade math and science from the beginning, it's only pretending to make these mistakes. So if you give it good advice, then it allows itself to stop making those mistakes. So from your point of view, you're actually teaching it. So it's a kind of learning by teaching system, or really a simulated learning by teaching system. And for those of you interested, I will reveal the secret identity that I have underneath this. This is called the World of Mathcraft. And if any of you are interested, I'd be happy to talk to you about it later.
So that ties in with a lot of themes. Would you call that artificial stupidity?
It's more like simulated learning by teaching.
Great. Okay, terrific. Well, thank you. So let's move in a little bit deeper now. Do you think that the ability of AI to test a lot of hypotheses really fast and effectively to fail faster means that the cost of being wrong is higher or lower than human intelligence? Do we need to worry more about letting AI run these simulations and come to conclusions than we worry with humans?
Well, mistakes are fundamental to how you learn. There's some people, like Perkins, who claim that we only learn from our mistakes. A slight exaggeration, but it's large part of what some people think is wrong with the school system is that we are doing too much of stuffing of correct stuff from the above and not allowing enough for mistakes to be made. And if you're learning something like skiing, you absolutely learn almost entirely from your mistakes. This basically leads me to discussing a very fundamental difference in how various kinds of AI work. Some AIs are like what Doug's been working on. You basically endeavor to be correct. You endeavor to use logic and reasoning and do the scientific thing at all points in time as much as you can. And the opposite end of the spectrum, which is the neural network crowd and all kinds of other AI systems that work on trying to learn, they are basically creating systems that start out empty and they make lots and lots of little mistakes, and they learn from their mistakes, and by refining their mistakes over time they get better and better. And so that's a radically totally opposed views of how to build an AI, and we're seeing a lot of activity in this fallible kind of AI as opposed to the correct kind of AI.
So fallibility versus correctness
Yes.
are sort of two opposing camps, if you will.
Absolutely.
Doug.
Monica, you ignorant slut.
I wanted controversy, now we're getting it.
Sorry, little Saturday Night Live humor. Anyway, no, I strongly object to your characterization of what we're doing as this sort of fallibility versus correctness dimension. One of the things that we learned very early on as we were building the psych system, even before that really, in AI, was that almost nothing is monotonically true outside of mathematics. Almost nothing is absolutely true. Things are only true by default. And so of the tens of millions of general common sense pieces of knowledge, not facts, but general pieces of wisdom, like you should hold glasses with the open end up and so on, that are in the psych system today, something like the vast majority, maybe 98%, are only true by default. And so what that means is as questions get answered, as problems get solved, you have proofs, with quotes around the word proof, you have arguments that are plausible, that are buoyed by these rules of thumb, by these usually true things. And so at the end, you gather up the pro and con arguments, and you decide, do the pro ones outweigh the con ones or vice versa, and based on that you decide whether to believe or how strongly to believe and take action on something. It's sort of like if I say, was Bill Clinton a good president? It's not like there's a right answer. There are lots of pro and con arguments, and the context that something is in is very important, and so we have to for 30 years now, we've had an explicit context mechanism in psych. So things are only true by default in a context, and they're true in some contexts and false in others. And so often something will be true at one time and false at another. They'll be true at what someone believes and false at another. They'll be true at some level of granularity, like Newtonian physics, and false at some other level of granularity, and so on. And so that's the way that reasoning works, not by propagating this razor's edge of true versus false, which is a kind of a 1960s way of thinking of the world, but rather by propagating these shades of gray with logical justifications behind them, with arguments behind them, and so that you can have a system that spends as much time as it needs to decide whether to believe something or not, but not by this kind of blind propagation of true and false.
Okay, Monica, you deserve a response to that.
So does psych learn from its mistakes, or does it require a programmer to go in and fix it?
So we do have the answer, I guess, is both. That a lot of what we have done for the last 30 years has been manually priming the pump to get the system to know the things that, in many cases, we learn when we're small children. In that 30 years, there have been an awful lot of toys and hair circumstances where people thought that was silly, and of course you could just start out a tabula rasa learning system, and in a year or 2 or 3 it would catch up and surpass. And so after 30 years of that failing, I think it's reasonable to say that it was probably a good idea to take the trouble to prime that pump. But having primed the pump, we can use that as a kind of inductive bias for learning, for discovery, so that instead of trying to just statistically learn things and discover things, you can use that almost the way Sherlock Holmes would, to deduce, to induce, to abduce things that follow from that. So if you find out that someone bought diapers, a lot of diapers 2 years ago, they probably have a 2-year-old now. And if you find out that they bought a bicycle a month ago, well, because of temporal projection, they probably still have a bicycle. And so if a new product comes on the market, like a child carrier for toddlers or something, you know without having any data at all to look at that this would be a reasonable person to market this to. You know, if you know enough about people, you could say, what is the market for this product going to be? So there's the possibility to answer questions which are effectively learning and discovery type questions. Scenario generation is another way that we use that. One of the sets of applications we do is for the military and the intelligence agencies to try to generate plausible terrorist attack and defense scenarios that represent attacks that haven't ever happened, but if you can think about them, if you can preconceive them in advance, then at very low cost with this large lever arm, you can change policies and information collection and so on to prevent those, or at least make them much more costly for anyone to try.
All right, Fred, what do you think? Do you have anything to say about this?
Yeah, I do. I'm not as smart as my esteemed colleagues here, so I got to keep it a little simpler. And the way I like to think about it is computers give us the ability to look at a lot of scenarios very fast. So go back 30 years and it was really difficult without, you kind of got experienced by the school of hard knocks. This worked or this didn't work. Now we can run scenarios that allow us to look at that. Once we've got that data or that right and wrong with an assertion and assumption, now the human gets involved.
It is connectionism and neural networks under another name, but there is a couple of things that have happened that are very important. About 60 years ago, when we started with artificial intelligence in 1950 and so the computers were very small, and the only thing we could do with them was basically do this behavior-based modeling. And then a few years later, many years later, the neural networks came along and people tried to make them work in their puny computers, and it didn't fly. And we have to remember the brain is large for a reason. If you want to attack problems intuitively, you have to have a lot of data. You have to have the right kinds of algorithms. And almost like a strike of lightning from a clear sky, about 2012, Jeff Hinton and people like John LeCun Jeff Hinton is from at Google, and John LeCun is at Facebook, and many others. Andrew Ng is now at Baidu. These people basically made neural networks and deep learning suddenly start working. And these 30 years of waiting for the neural networks and intuition-based systems to catch up, basically we are seeing that happen right now. In only like in 2009, they got speech recognition working much better than before, and in 2012 it appeared in your Android devices. So the speech recognition you have in Android is basically based on deep learning, and it works really well. Google had this cat recognition project that independently from unsupervised learning determined that this picture is the cat. And that's a big deal because unsupervised learning is much harder than supervised learning. So these new methods have proven themselves suddenly to be very, very powerful, and that is largely because of, well, there's 3 factors. There's basically the fact that you using deep learning, which at the short explanation is you can only learn what you already almost know. You have to start by learning what the sensory input means, and then you build, that becomes an alphabet at the next level. And you don't train the higher level until you have lower levels, it's like fully functional. And by doing this little trick, you can learn very deep neural networks. The second thing that helps is much, much larger computers. I have a computer in my garage that has 512 gig of RAM and 64 cores, and that's basically something you can buy if you're doing a little bit of research. And at a moderate cost. And then the third thing is that we have training data. Internet has all kinds of text. YouTube has all kinds of videos. There's an infinite amount of cat pictures on the web. So you can trivially gather a very large corpus of training data for your system. And you can look at the text under the picture and say, if it says cat, it's probably about a cat. So both supervised and unsupervised learning, they benefit largely from the internet, from larger computers, and from a small number of tricks such as deep learning that we have learned in the past few years.
That was a very good answer, thank you. Do you have anything to add?
Yeah, I do want to say that was a great answer. And the only thing I would add to that is that deep learning in many ways is tapping into the sort of right brain source of power of noticing patterns. But if you think about, say, your airplane flight over here or something, while you want your pilot to have had his or her 10,000 Malcolm Gladwell hours of becoming an expert, of building up those patterns in their right brain, you also want them to understand what each of the instruments is telling them, and to understand what each of the controls does, and to be able to use that knowledge and how airplanes work and how flight works and so on in order to cope with novel and unexpected situations. And so in cases where you do expect novel situations to be part of the task, to be part of the domain, to be part of the problem, like for example in most of the real world, then you really need to combine both of those sources of power, not just deep learning, but also having the sort of logical, deep understanding of the way that part of the world works.
Would you say there's a kind of two camps, a kind of right brain approach and a left brain approach to AI, and that's actually one way to characterize these trends?
Absolutely, and there's constantly this sort of hype curve that the Gartner Group talks about, where there are AI sort of winters and summers and so on, and the same thing happens with the left brain and right brain approaches in AI, where at some time one of them will pull ahead and appear to be the panacea, appear to be all that you need, when in fact really you should think of them as tools in a toolbox. It would be silly to build a house with only a saw, and it would be silly to build a house without a saw.
Yeah, I think the innovations that are happening are from using all forms of AI and the best tool to accomplish the task that you're working at. So when we get into profession, there's lots and lots of evolution of computer power, algorithms, approaches. So the real fun is taking those algorithms and approaches and combining them to produce a solution that's good for a human. And so it's really exciting that these things are coming along, and we shouldn't get in one camp or the other. We should think about, how do I solve the problem? What's the best approach for solving the problem? And how do I use the best in current research for solving that problem?
So what's holding research back? What do you think the edge is right now? How would you define the new frontier in AI? What are the next big problems that you think we'll be solving, let's say, in the next 10 years, and what do you expect?
Well, what I think is researchers often get into their camp and they don't get out of their camp. So that's problematic by the nature of it. So it's more about collaborating across different techniques and using those to do different things. But I also think there's each time we do better and we produce working software that humans use, then their expectations get higher. And as those expectations get higher, we, as delivering products, have to do a better job. So I think that the limitation is essentially the expectation of how should this work? What can you do for me?
Okay, I can give you a surprisingly concrete list of things that are holding back and progress in AI. So one is a very technical problem, and then the others are almost more societal problems. So the technical problem is one of inferring the right context for something that you've heard or read. So you see something on the internet, and you as a human have relatively little problem putting that in the proper context, understanding what ideological acts the person who wrote that had to grind, or when it was written. Obviously, it was written 50 years ago. You take it differently than if it was written 50 days ago, and so on. So in logical terms, if you know or believe P is true in some context, say C1, and you know or believe P implies Q in some other context, C2, then you want to conclude Q is true, but how do you figure out the context, C3? to assert Q-in properties. So that is what I consider to be the key intellectual challenge that symbolic AI has to grapple with. The other problems that are, the other limitations that are holding us back, I think, one is we need to have a bunch of different interfaces, 10, 20 different interfaces that people with different ways of approaching the world, different tasks, different levels of sophistication and familiarity with logic and AI and so on, could use. And some of them will look a lot like Fred's interactive agents, and you'll want to communicate via conversation. Some of them will look more like connecting the dots, graphical things. Some will look more like math or programming or logic expressions. And so if we can build those interfaces so that millions, billions of people can be participating in the gradual education of a kind of growing world AI, I think that is the other limitation. And it's a limitation that we're on the verge of conquering, which is very exciting. And then along with that is, and this is the last one I'll mention, is somehow incenting people to do that. Some of you, in fact almost all of you in this room, would have enough interest to spend your time helping to educate that AI in the same way that so many millions of people have contributed to Wikipedia and so on. But instead of representing things in English, represent them in a way that the machine can actually manipulate and logically combine the same way that, that you would. So how are we going to incent that? Through some sort of micropayments maybe, where the people who pay for the results eventually those pennies get divided into millionths of a cent that go back to the people who added the knowledge to begin with. Maybe you incent them through some kind of gamification process or something.
But shouldn't the goal just be to make something that can read the Wikipedia and learn from it?
So I think that for a lot of us, that is certainly one motivation. But if you mean, is that sufficient? Absolutely not. And that is the blind spot that so much of AI has had. If you think of all the things written down in Wikipedia, or even all the things written down on the web, think of that as like the black space, the black type on white paper. But the real missing component to AI is the white space. It's all the things that the writers assumed the readers already knew about the world when they wrote their Wikipedia article. And it's those tens of millions of things that we almost never say out loud, we almost never write down. And that's what's really holding back AI. That's what's separating AIs that are severe autists, having the veneer of intelligence, from deep human breadth and human scale AIs that you basically entrust your kids to, or sharp knives and open flames to, and so on.
Monica, what do you think about all this, and how does intuition play into AI, and how does teaching, should we teach an AI more like the way we teach a human, or should we expect it to learn more like a computer learns?
We should expect it to learn more like a child learns. And in spite of what parents think, their children learn most of the language by observing parents talk to adults talk to each other. The corrections that parents do are a very minuscule, very small part of the child's learning of language. I'd like to briefly address Fred's point here about changing opinion about AI. I changed from, after doing traditional AI for about 20 years, I changed to doing this holistic, this intuition-based AI in 2001. And that gave me basically, I got into deep learning early because I just by chance discovered deep learning techniques along with many others over these past few years. And now we're seeing a stampede of people who've been working on the logic end of AI, moving over to the deep learning and to neural networks in areas such as vision and sound processing. At the slightly deeper level, right brain versus left brain, that is a myth. The right and left isn't really there, it's all over the place. But it's a very important distinction. Yes, that's roughly what we're talking about. If you read Thinking Fast and Slow by Daniel Kahneman, we have the same division in AI. The slow thinking, the reasoning is the kind of stuff that Doug and many others have been working on for many years, and fast thinking, the parallel stuff, the intuitive understanding of a situation based on multiple overlapping patterns and other things like that. That's the fast thinking. And Kahneman has a wonderful proof, if you will, in his book about both of them actually are used by the brain, where you can, basically they have this property that the slow thinking can be stopped and resumed. You can reason about something and then take a break and come back and reason about it later. Whereas understanding is this instantaneous thing. An example of that is understanding language. Once you learn to understand English, you cannot turn it off.
Intuitive understanding.
Intuitive understanding. Yes. Once you learn to understand intuitively language, you cannot turn it off. And that basically proves to me that there are two kinds of thinking going on in the brain. And if you look at certain psychological tests, we notice that the brain spends like much more of its cycles on the subconscious understanding than it does on the conscious reasoning. The factor is enormous. It's 100,000 times more of the brain cycles are used for intuition than for reasoning. And this kind of implies to me that we have been looking at intelligence wrong. The reasoning part is the sugar on top, it's a paint-thin layer on top of our intuitive understanding. And we need to change over to create systems that have this kind of intuitive understanding as the base. And then we will eventually get to reasoning at the end of that.
Do you think that sort of maps to biology too? I mean, you look at evolution, most of the time it's been spent on the lower levels of the brain and effectively intuitive understanding, or this real-time processing versus kind of more recent developments around reasoning in the higher levels of the brain?
Look at animals. I mean, dogs understand a lot, but they don't reason much.
So I think it's interesting to take this concept of context. So let's think, sometimes we make things a little more complicated than they need to be. So context is purely a variable or a set of variables that allow me to understand better. So let's just take computers out of it for a minute and talk about human-to-human conversation. We infer, we use intuition, we use lots of things to put context around a conversation with another human being. But if we're good at communicating, we quite often ask clarifying questions and validate that context is appropriate and right. So if you think about trying to help a human with AI, what you want to do is take this context that you infer, think, or maybe have. I call it personalized data. It's knowing you, right? By knowing you, that's a form of context that allows me to help service you better. But let's say I don't know for sure. You can do something that humans are very good at and computers aren't so good at, but getting better. You ask a very simple question. And us geeks, we want to do things without asking because we want to be intelligent. We want our AI to be really good. In reality, what makes good AI is communication with the end user and asking them for what's relevant, remembering what's relevant, and even learning from watching their behavior. Trying to get context out of a bunch of data is really hard, but trying to get context from a human by asking is very simple.
So I think clarification dialogue, like Fred is talking about, is extremely important and is absolutely the way to go for a very large number of interactions. I know I said there are going to be lots of interfaces, but clarification dialogue in a natural language like English is probably going to be the number one most useful way that will happen. But don't forget that computers can help with that, AI can help with that by generating large populations of what-if scenarios. If they have the ability to do so, if they have this sort of deep understanding of the world, this sort of logical understanding, not just intuitive understanding. And even, I suppose, with intuitive understanding, they could still imagine alternatives. And then, imagining all these different alternative scenarios, they can decide which differences in, which disambiguations of what they just heard from the human really matter and which ones don't matter. So they can do a kind of symbolic sensitivity analysis. And based on that, they can decide what to bother clarifying or what to just defer. It's like, well, I didn't really understand which of these two things you might have meant, but you know what, it doesn't really matter, and maybe later in the conversation you'll say something that disambiguates it, or maybe we'll get to the end of the conversation and it still won't matter. And so that, I think, is a kind of a complement to what Fred was talking about, is being able to decide when to bother and at what level to bother clarifying the things that you, the computer, didn't quite understand in what the human user just said to you.
All right, does anybody have a burning question that you'd like to ask the panel? This would be the time to come on up to the microphone. We'll just take you in order. Just come up to the mic and line up. It's just easier if you line up, and we'll just take your questions. We have about 5, maybe we can go a little bit over, but not too long. So let's make your question quick, and then you guys have to answer quickly too. Go ahead.
Is humans' ability to ascertain context really not replicatable by AI? Don't we have to consider ourselves sort of magical creatures in order to think that we can't ultimately figure out that puzzle and then be able to put that into machine intelligence?
Oh,
140 characters.
Sorry.
I think we absolutely can have our AIs solve and work on that problem, but it's a very difficult one, and it's one which is often glossed over. The narrower your task domain, the less you have to attend to it. And historically, our applications have been so narrow, we've been able to ignore that issue of context. And as we're talking about general AI, we can't ignore that anymore.
Okay, thank you. Next.
Can I answer that?
You can answer it, but I want to give everybody a chance.
Yeah, my
I wanted to
answer-
ask the panel if they thought that we're in a similar situation to Europe was in the 17th century before the invention of calculus, and that in fact we need a whole new branch of mathematics in order to describe AI.
It's a cool idea.
Okay, so I will say that that is obvious physics envy. And while that can serve some people in some fields in good stead, it is actually it is almost the antithesis of what I think, at least, we need to be doing, that AI needs to be doing, and that we are in a pre-mathematical, pre-formalization stage, a pre-heuristic stage almost, of understanding of intelligence. We need to do experiments, and maybe we're in the Middle Ages, and eventually we'll come up to the level where we can do the mathematization and the formalization that will fit on a t-shirt like Maxwell's equations do, and so on. But that doing that now is more likely to lead to kind of mental masturbation than anything else.
Anyone else?
I would like to claim basically that we are in the opposite situation. 1700s, etc., was the birth of reductionism, of basically figuring out complex situations by simplifying them, by removing that which is irrelevant, and creating simple models that we can reason about. And here we have to, basically, we are at the point where we have to stop being as scientific as we are. When we're making an AI, we have to make an intuitive machine that jumps to conclusions on scant evidence, that uses correlations, not worrying about causation and so on. We have to make machines that are as naive in their intelligence as teenagers or newborn children. And
So a more evolutionary approach where it's
more
okay to be wrong.
Not even evolutionary, more basically, yes, a intuitive approach. And that's viewed today as unscientific, and one of the problems with AI is that we are still trying very hard to be scientific, where we really should be going in the other direction and being more intuitive, holistic even.
But we can be really practical and really helpful right now.
Thank you.
Thanks. Next.
Yeah, hi. I was wondering, just from a sort of futurist perspective, maybe looking 20 to 30 years out, what you think might be around, to help people in their day-to-day lives, like consumer, applications and such.
If you've seen the movie Her, the first part of that is basically where I think we're going. On one hand, we're going to have big AIs or millions of AIs in places like Google that are doing stupid things like classifying web pages. But for the individual, I expect that we have. But for individuals, I expect we're going to have basically machines that we talk to on a daily basis, which I call confidants, but basically look exactly like in the movie Her. We talk to them and they talk back, and it makes sense. If you have a question, you ask it, it will give you the answer. If it knows, otherwise it does a web search. If you can't get that, it talks to another confidant over the web. If they don't know, they will ask their user.
Yeah, so I would go even farther and say that our personal intelligent assistants, sort of cradle to grave, will be modeling us, helping us, amplifying us, understanding us well enough that in general we'll just start to formulate a question. and it'll know what we're about to ask and answer. We'll start to make a gesture, like an old married couple. It'll complete it for us. So something that appears almost like weak telepathy.
Well,
If you're walking down the street and you yawn, you don't really want a bed to roll up.
No, but that's the point is that having lived with you
Context.
and modeled you since you were born, it figures you were probably just yawning. And then the second thing, besides the sort of weak form of telepathy, is kind of weak form of immortality, where the model of you will be so good that you'll begin to delegate more and more purchasing decisions, interactions with other human being decisions. Eventually, when you die, people will still talk with you in the sense that...
So why even live?
Well, the reason it's weak immortality is that it will matter to you, it just won't matter to everyone else that you're in.
We just become kind of blobs that have, we don't have to know anything, we don't have to interact with anyone, we don't have to remember anything. Is this good?
Well,
No, it's the opposite. You're going to learn more because of your personal assistant, and you're going to evolve your mind and your knowledge and what you like to do to a higher level, because trivial tasks won't have to be done by you. And we're learning, we're evolving as a species, and the more we know, the smarter we can get, the more we can have in our mind. It's automating things that we do now to give us more time to do more artistic, more helpful things.
Although, they do say that doing trivial tasks, for example, prevents age-related dementia.
Correct.
Yeah.
So are we just not going to do trivial tasks and hopefully think about art and philosophy, but just become demented?
Yeah,
Philosophy helps us with dementia, trust me. We can have logical arguments and debate and discussions and learning. That's learning, in my opinion, is what helps with dementia. We're going to challenge the mind every day,
So
and I think it will be challenged more.
you Nova's last question is, I think, really the crux, the cusp that we're at right now. Almost a kind of good versus evil decision that the world is going to make, that you're going to make. And it's going to be, will AI make us smarter or will it make us dumber? And it's a real choice whether we're going to move in the direction of Eloy versus Morlocks, whether we're going to more in the direction of kind of Star Trek computer where people are amplified, more rational because of AI. If you look at what calculators have done, they've basically destroyed the current generation's ability to estimate, to understand math, and so on. So yes, people make fewer math mistakes, but they don't understand math and they can't estimate. In much the same way, Google is swaddling us, and the AIs that we're talking about here will swaddle us to enable what biologists who study insects would call juvenilism, so that essentially for your whole life, people will have to know less and less and less and understand less and less and less about the world. The world will become a kind of magical place where people don't really understand anything because they don't have to. So that's one direction, that's one fork in the road, one path to take. And the other is to have, as Fred was saying, have an AI which challenges us, which educates us, which works with us almost Socratically, forcing us to become smarter and understand the world in a deeper way than we do. And I think we're really poised on the balance, almost on the knife's edge, where things could go either way.
So, who knows about the Young Ladies Illustrated Primer? That's
Yes.
where I want to go.
The
That's where I want to go.
diamond age.
Diamond Age. You want to have a machine that you basically, the moment you know how to speak language even a little bit, you get the device that you talk to all your life long, and it basically brings you up, it brings you forward, it tells you things when you, before you even know how to ask.
So one paradigm is AI that protects us from the world, and the other is AI that helps us be more human.
Yeah, and I think it's our choice to build those. I know what I'm going to build.
Next question.
So will the AI reach to the point that it can teach itself, make it smarter and take a new algorithm? So my question is, will AI be able to create its own algorithm and make it smarter by itself? Okay, it's kind of question.
Right, this is the recursive self-improvement question. And my answer to that is that, we've known since the 60s, McCarthy and Hayes' paper about the frame problem, that the world changes behind your back. And the fact that the world changes behind your back is what sets the limit for how powerful intelligence is. You can have all the world models you want, but if they're obsolete, you will not make the right decisions. All intelligences are fallible, and we just have to live with that, including all the artificial intelligences.
What about the singularity? Is that hype, or is it going to happen?
We're gonna get we're gonna get better and better at many things, and but don't think about the AI singularity. I think that's impossible, mostly, as I said, because of intelligence is limited by world complexity, and adding AIs to the world makes it more complex. So I don't see. I see that basically a slow progression towards better and better machines, like new releases of Siri will suddenly get better and better. And that's how a lot of people will encounter AI the first time that
Fred, you had something to say, I think.
Yeah, I mean, there's self-consciousness or this ability to be creative, innovative. That's a human characteristic, even the characteristic of having a spirit. So as a human, we can predict the future without a past, right? Computers can't do that. They've got to look at data and make decisions from data. They're not self-conscious. They're not that creative type that can go out there and invent something. That's what humans do. And I think there's logical proofs of that. It's not an opinion, it's a proof. Computers can't do that.
So for 40 years, we've had computers that do exactly that. If you look at AM and Eurisco and Bacon and 40 or 50 other machine discovery programs, of course they've done that, and there's nothing special about the human ability to discover things and invent things and come up with creative new ideas. So I believe absolutely the answer to the question is a simple yes. But if you talk about singularity, then I think the right way to look at it is that if we go down the fork in the road that I was mentioning, if we go down the path that leads to us being smarter as individuals, genuinely understanding the world better as individuals, then as a species, we will be qualitatively smarter. And when was the last time that we as a species got qualitatively smarter? You have to go back 100,000 years to the discovery of language. And we look back on pre-linguistic cavemen sort of sadly, pitifully, and say they weren't quite human, were they? And I think at some point people will last pre-AI generation with the same kind of pity and say it's too bad they weren't quite human, were they?
So basically you want to avoid the dumbularity, is what you're saying.
Yes.
Next question.
Speaking of the dumbularity, I've heard some concern that the algorithms we build have the social biases that we bring to them, and that we're building a world that is full of social biases that are, will only become apparent to us over time just